Hello everyone, welcome to the lecture again. In the last few classes, we find out the expression of the velocity and acceleration in Cartesian coordinate, planar polar coordinate, spherical coordinates and cylindrical coordinates. So, let me summarize these results first and then we will look at some of the examples. So, we saw that in Cartesian coordinate, the velocity vector which is r dot is x dot I plus y dot j plus z dot k, and the acceleration a is r double dot and it was x double dot I plus y double dot j plus z double dot k. Okay. And of course, in Cartesian coordinate we have x axis, y axis and z axis. In planar polar coordinate, we have vector v equal to r dot r cap plus r theta dot theta cap, and the acceleration a was r double dot minus r theta dot square r cap plus r theta double dot plus 2 r dot theta cap, wherein the coefficient of r cap is the velocity and acceleration in the radial direction and the coefficient of theta cap is the velocity and acceleration in the theta cap direction. Here let us say this is x axis, this one is y axis, then we have some point P. So, this is your r and the angle that it makes from the x axis is theta. We also saw that if r is constant, then it becomes circular motion. And in this case, because r dot and r double dot will be 0, therefore, velocity vector v becomes r theta dot theta cap and acceleration a becomes minus r theta dot square r cap plus r theta double dot theta cap. In spherical coordinates, we have velocity vector v is equal to r dot r cap plus r theta dot theta cap plus r sin theta phi dot phi cap, and the acceleration a can be written as a r r cap plus a theta theta cap plus a phi phi cap, where again a r, a theta and a phi are the acceleration along r, theta and phi direction. Here a r was r double dot minus r theta dot square minus r sin square theta phi dot square, and a theta was r theta double dot plus 2 r dot theta dot minus r sin theta cos theta phi dot square, and a phi was 2 r dot phi dot sin theta plus 2 r theta dot phi dot cos theta plus r sin theta phi double dot, and again here you have x axis, y axis and let us say z axis. Then r is the position vector of this point P, and the angle that it makes from the z axis is theta. So, this is the z axis, this one is the y axis, and its projection on the xy plane, whatever angle it makes from the x axis is your phi. Okay. Now, in cylindrical coordinates, we have velocity v equal to r dot r cap plus r phi dot phi cap plus z dot k cap, and again the acceleration a is let us say a r r cap plus a phi phi cap plus a z k cap, where this a r is r double dot minus r phi dot square, a phi is r phi double dot plus 2 r dot phi dot, and a z is just z double dot. All these expressions we have derived in the previous classes. Let me again say that in cylindrical coordinate system you have let us say a point P that you want to represent. So, you draw a cylinder of radius r, and its projection, the projection of r on the x and y plane, whatever angle it makes from the x axis was phi, and the height of the cylinder was z. Okay. Now, with this background, let us look at some of the examples. So, the first problem statement is following: the curvilinear motion of a particle is defined by Vx equal to 50 minus 16t and y equal to 100 minus 4t square, where Vx is in meter per second, y is in meter, and t is in seconds. It is also known that x equal to 0 when t is equal to 0, and we have asked to determine its velocity and acceleration when y is equal to 0. Now, the first thing that we have to identify is the right coordinate in which this problem can be solved. Now, you can see that Vx is given and y is given, therefore, the natural choice is the Cartesian coordinate. Okay. So, let us look at Vx is given, it is 50 minus 16t. Therefore, from this I can find out what is the x and what is the acceleration along the x direction. X I can find out by integrating this Vx with respect to t. So, we have 50 minus 16t dt, that is equal to 50t minus 8t square meter, and the acceleration Ax we can find out by differentiating Vx with respect to t. So, that will be d over dt, Vx is 15 minus 16t, and this comes out to be minus 16 meter per second square. So, now we know x and Ax. Let us now find out Vy and Ay. For that, y is given, okay, y is 100 minus 4t square. Therefore, Vy will be d over dt of y, which is 100 minus 4t square. Therefore, this becomes minus 8t meter per second. And acceleration Ay we can get by differentiating Vy with respect to t. So, it will be d over dt minus 8t equal to minus 8 meter per second square. Now, in the problem statement we have been asked to find out the velocity and acceleration when y is equal to 0. Therefore, let us see the value of velocity when y is equal to 0. So, when y is equal to 0, then you can see from equation number 1, let us call this equation number 1, that t comes out to be 5 seconds. Okay. So, let us put y equal to 0 equal to 100 minus 4t square, therefore, t square is equal to 25 or t is equal to 5 second. Now I can find out what is Vx when t is equal to 5 second or when y is equal to 0. So that will be 50 minus 16 and t becomes 5. So that is minus 30 meter per second, and Vy will be minus 8t. So minus 8 into t is 5, which is minus 40 meter per second. Therefore, V, which is Vxi plus Vyj, becomes minus 30i minus 40j, or its magnitude is square root 30 square plus 40 square, which is 50 meter per second. Now, the acceleration A will be Ax, which is minus 16i, plus Ay, which is minus 8j, and you can find out its magnitude. It will be square root 16 square plus 8 square, which will be 17.9 meter per second square. Now, let us look at another problem. Here the problem statement is pin P at the end of the telescopic rod slides along the fixed parabolic path y square equal to 40x, where x and y are measured in millimeter. The y coordinate of P varies with t, which is measured in second. According to y equal to 4t square plus 60 mm. When y is equal to 30 mm, compute number 1, the velocity vector of P and the acceleration vector of P. Okay. So, again in this problem you can identify that the problem can be solved easily in the Cartesian coordinate, because the relation between x and y is given. So, we know that in Cartesian coordinate the velocity v is x dot I plus y dot j, and the acceleration a is x double dot I plus y double dot j. Therefore, to find out the velocity and acceleration, we should know what is x dot, x double dot, y dot and y double dot. Okay. So, let us see the information that is given in the question. It is given that y varies as 4t square plus 6t, and the relation between y square and x is y square equal to 40x. Therefore, I can find out how x depend upon t. So, x will be 1 over 40 and y square. So, y square will be 4t square plus 6t whole square. Let me call this equation number 1. Therefore, x becomes 0.4 t to the power 4 plus 1.2 t to the power 3 plus 0.9 t square. So, now we know what is x and what is y in terms of t. So, I can easily find out the x dot. X dot is 1.6 t to the power 3 plus 3.6 t square plus 1.8 t millimeter per second. Now, to find out the value of x dot, I should also know what is t, at what instant I am calculating the x dot. So, to find out the t, it is given that you have to find out when y is equal to 30. So, let us put y equal to 30 in equation number 1 to find out the t when this happen. So, we have 30 equal to 4 t square plus 60, and this gives you t equal to 2.09 second. I can put this value over here and you will get x dot equal to 34.1 millimeter per second. Now, let us look at x double dot. X double dot will be 4.8 t square plus 7.2 t plus 1.8 millimeter per second square, and you can put t equal to 2.09, you will get x dot equal to 37.8 millimeter per second square. Similarly, y dot will be, you can use equation number 1, it will be 8 t plus 6 millimeter per second, and put t equal to 2.09, you will get 22.7 millimeter per second, and y double dot is equal to 8 mm per second square. Let us put that in this equation. So, you get v is equal to 34.1 I plus 22.7 j millimeter per second, and acceleration A is equal to 37.8 I plus 8 j millimeter per second square. Now, let us look at another problem statement. Question number 3. A test car starts from rest on a horizontal circular track of 80 meter radius and increases its speed at a uniform rate to reach 100 kilometer per hour in 10 seconds. And we have asked to determine the magnitude A of the total acceleration of the car 8 seconds after the start. Okay. So, first of all, it is clear that the motion is circular, and it is also given that the transverse acceleration is constant. So, it is given that at is constant. Therefore, we can use the simple equation v equal to u plus at, and it is also given that initially the car is at rest. Therefore, at will be v over t, and v is given, it is 100 kilometer per hour. So, 100 into 1000 to convert it into meter, and hour, let us convert it into second, multiplied by t. So, it attains this in 10 second. So, therefore, 10, and you get the transverse acceleration, which is 2.78 meter per second square. Now, the tangential velocity at 8 second will be 2.78 meter per second square into 8, which is 22.2 meter per second. And now I can calculate what is the normal acceleration or acceleration along r. It is r theta dot square, or we can write down r omega square or v square over r. Now v is known, r is also known, therefore a n will be 22.2 whole square divided by 80, which is 6.17 meter per second square. So therefore I know the acceleration in the tangential direction, I have calculated the acceleration in the normal direction, therefore a total will be square root a t square plus a n square, which is equal to 2.78 square plus 6.17 square, and it comes out to be 6.77 meter per second square. Now let us look at another problem statement. Question number 4. Consider the polar axis of the earth to be fixed in space and compute the magnitude of the velocity and acceleration of a point P on the earth's surface at latitude 40 degree north. The mean diameter of the earth is 12,742 kilometer and its angular velocity is 0.7292 into 10 to the power minus 4 radian per second. So in this problem, first of all you have to realize that point P is making a motion in circle, and for circular motion we have velocity v equal to r theta dot and acceleration a r equal to r theta dot square, wherein this r is the radius of the circle, and from the geometry you can see that small r is capital R cos 40 degree. So let us put it over here, you get v equal to r cos 40 degree theta dot, and this will be 12742, this is kilometer. So let us convert it into meter, multiply by 10 to the power 3, divide by 2, because 12,742 was the diameter, multiply by cos 40 degree and then theta dot. Theta dot is given in the question, angular velocity is 0.7292 into 10 to the power minus 4. So let us multiply it by 0.7292 into 10 to the power minus 4, and this comes out to be 356 meter per second. Now let us see AR. AR is r theta dot square. So r is capital R cos 40 degree into theta dot square. This will be 12742 divided by 2 into 10 to the power 3, and then we have cos 40 degree and then theta dot, which is 0.7292 into 10 to the power minus 4 whole square, and this comes out to be 0.026 meter per second square. Now let us look at one more problem. and the problem statement here is following. The plane motion of a particle is described in polar coordinates at r equal to 1 plus t square meter and theta equal to t square divided by 2 radian, where the t is measured in seconds and we have asked to find the magnitude of the acceleration when t is equal to 2 seconds. In this question it is already given that the motion is happening in planar polar coordinates, and in planar polar coordinate the velocity v is r dot r cap plus r theta dot theta cap, and the acceleration a is r double dot minus r theta dot square r cap plus r theta double dot plus 2 r dot theta cap. So, we have to find out what is r dot, theta dot, r double dot and theta double dot. It is given that r is equal to 1 plus t square, and all this thing we have to find out at t equal to 2 second. So, therefore, this becomes 5, r dot becomes 2t which is 4 and r double dot becomes 2. Now, theta is t square divided by 2, therefore, this becomes 2, theta dot becomes t, therefore, let us put t equal to 2. So, this again becomes 2 and theta double dot becomes 1. Let us put them above. So, we get v equal to 4 r cap plus 5 into 2 theta cap. So, we have 4 r cap plus 10 theta cap, this is the velocity, and its magnitude will be square root 4 square plus 10 square, which is 10.77 meter per second, and acceleration a becomes r double dot minus r theta dot square. So, this is 2 minus 5 into 4 r cap plus 5 into 1 plus 2 into 4 into 2 theta cap, which is nothing but minus 18 r cap plus 21 theta cap. Therefore, the magnitude of a is square root 18 square plus 21 square, which is 27.66 meter per second square. With this, let me stop here. See you in the next class. Thank you.